Okay, so this equation, or sorry, this lesson is on the equation of a circle. Okay, so far you know the equation of a line. And now today we're going to learn the equation of a circle. Okay, see how it looks different than the equation of a line is one thing we'll notice. So we're learning to determine the equation of a circle with a center of 0, 0. That's the easier version. And then we're going to learn how to figure out the equation of a circle that has a center anywhere. Okay, so it can have a center at 3, 4, or -2, -1. Okay, that equation's a bit more complicated, but we'll all get there. Okay, so our first example is to determine the equation of a circle that has a center of 0, 0, and a radius of 5, which is the one that you see in front of you, by applying the length of the line segment formula. Okay, so the center is 0, 0, so I'm going to put a point here, and usually when the center is at 0, 0, they use O for origin rather than C for center, but when it's somewhere else they use C. Okay, O stands for origin because the coordinates are 0, 0. And then what we want to do is choose a point where we don't know its coordinates, but it's on the outer edge. So like a point there where I'm not sure what its coordinates are. And I'm just going to call it point P, and its coordinates are going to be some x value, some y value, but it's on the circle. Okay? Now if I join those points, the origin with point P with a ruler, I know something important about that line segment. I know its length. What is it? 5. Is everybody good? I know it's 5 because it's the radius of the circle, and the circle has a radius of 5 no matter where I draw the center to any point on the outside, it's always 5. Okay? Everybody good with that? So if I use my distance formula based on these 2 points, and I label this one x1 and y1, and this one x2 and y2, and I'm just going to recopy this distance formula that we used this morning. We're going to actually create the equation of that circle by applying the distance formula. Okay, that's what we're going to get to, the equation of a circle. And we'll be able to look at it and see how it looks different from the equation of a line. So because we know this distance is 5, we can replace d with 5, because we know the distance between the point 0, 0 and the point on the outer edge of the circle is 5, because it's the radius. Okay? And now if we substitute in x2 is just x. You see that? We labeled x2 to be our x. So I'm going to put a bracket here, and then I'm going to replace x2 with just x. Then there's a minus sign in the formula. And what was x1? 0. And then that's in the formula still being squared. Okay? Plus, what did we label to be y2? Y, good. So y2 ends up being just y. There's a minus in the formula. And y1, because it's the origin, is 0 again. And then that's squared. So then I've got 5 again. But the nice thing about x minus 0 is it's just x. Is everybody good? X minus 0 is just x. But it's being squared. So I have x squared plus y minus 0 is just y. So y squared. So that's an ugly looking formula for the equation of a circle. Does anyone remember how you undo square root? What do you do both sides to undo square root? Square, good. So if I square this side to undo square root, I also have to square this side. Okay? Which means I would get 25, and all this squared does here is undo this square root. So I just end up with x squared plus y squared. And then because it's an equation, we turn it around because the equation of a circle with center 0, 0 looks like this. X squared plus y squared equals 25. Okay? But that number 25 represents radius squared. Because remember the radius was 5? So this number here represents the square of the radius. Okay? So in general, and I'm sure I have that on your note, but I'm going to put it up here. The equation of a circle with center 0, 0. It's pretty easy to remember. It's always x squared plus y squared equals r stands for radius squared. Okay? So that's the equation of a circle that has a center of 0, 0. All right. In general, oh, did I miss something? Okay, good. Yeah. Is the point 4, -3 on the circle? How can you be mathematically sure? This is an important question. There's a question on the assignment tonight, and I think we'll have probably more on the practice. But what you do is a left side, right side check, which we're getting really good at doing. So if this point was on this circle, whose equation we know, it would have to work out for the left side, right side check. So we look at our equation of our circle. We've got more on the left side, so we're going to make our T-chart. So we've got more room on the left side and less room on the right side. Copy out what's on the left side of our equation of our circle. It's x squared plus y squared. Copy out what's on the right side. It's 25. And we're checking if it works out when x is 4 and y is -3. Okay? So then we're just going to substitute in. We're going to replace x using brackets with 4. Now we're going to replace y using brackets with -3. So 4 and -3. And then we just use our calculator. So positive 4 squared is 16. -3 squared is positive 9. And when we add them together, we do get 25. So we get left side equals right side, which means, so since left side equals right side, comma, 4 -3 is on the circle. Now, the thing about circles is often a question will ask you, is this point on the circle, inside the circle, or outside the circle? So if I had worked this out and instead of getting 25, I got 20, would the point be in the circle or outside of the circle? And how do you know? Inside, because it's less than 25, right? Yeah, perfect. And if I'd gotten 30, it would be outside the circle because it would be bigger than the right side. Okay? So often that's a question they'll ask because it's a circle. Is it on it, inside, or outside? Okay? Alright, so in general, the equation of a circle having radius r centered at the origin 0, 0 is x squared plus y squared equals r squared, where r stands for radius. Okay, x squared plus y squared equals r squared. So note, lines are defined by their slope. So these are lines. Lines are defined by their slope and their y-intercept. Whereas circles are defined by the location of their center.
You're at origin.
Use center because origin means 0, 0. And the length of the radius. Okay, so if you knew where the center was and you knew what the radius was 2, you'd be able to, everybody draw the same circle. Plot the center and then go 2 over, 2 over, 2 up, 2 down. And you'd be able to all draw the same circle. Just like in grade 9, if I told you where the y-intercept was and I told you what the slope was, everybody would draw the same line. Okay? All right, circle, example 2, circle the equations that represent lines and put boxes around the equations that represent circles. I know that's backwards, but that's what we're doing. So if it's a, circle it if it's a line, and put a box around it if it's a circle. So see what you think, and see if you can tell the difference. So we're trying to see what's different about the equation of a line versus the equation of a circle. Okay, who thinks they know whether the first one is a line or a circle? Yep, it's a line. Good. So it's a line, and we were supposed to put circles around the line, right? There we go. And why did you know it was a line? Right, so it's in the form y equals mx plus b. Good. How about the next one? Circle or line? Circle. So this one's a circle because it's in the form x squared plus y squared equals a number which represents the radius. The next one, 3x minus 4y equals 12. It's a line, good. Even though the x and the y are both on the same side, they only have exponents of 1, okay? Whereas in a circle, they would both have an exponent of 2. So that's a line. And then x squared plus y squared equals 81. Circle. So they have the squares on them. X and y both have an exponent of 2. Okay? So example 3, determine the equation of each circle if you know its center is 0, 0, and its radius is given. So we know it's going to follow this format. X squared plus y squared equals radius. Okay? So if the center is 0, 0, we already know the left side of the equation is going to be x squared plus y squared. We already know that if the center is 0, 0. Okay? And then we know that the right side is going to be whatever the radius is squared. So in our case, the radius is 11. So I might write that middle step in there and put 11 squared there. But instead of leaving it like that, I'll actually put 11 squared into my calculator and get 121. So the equation of a circle that has a center at 0, 0 and a radius of 11 is x squared plus y squared equals 121. Okay? Radius is 1 unit. So again, center is 0, 0, so I know the left side of my equation is x squared plus y squared. And the right side is going to be 1 squared. And be careful because 1 squared is 1. Oops, I'm just going to plot this on Desmos so you can see that you can put circles in Desmos as well. So I can type in with the little keyboard here, x squared plus y squared equals 1. And there's my little circle with a radius of 1. Okay, or I can change 1 to 121. And I have to shrink down so you can see that it has a radius of 11. Okay, and notice the center is 0, 0. Okay. All right. Radius of square root of 6. So again, because the center is 0, 0, we know that the left side is x squared plus y squared. And we know the right side is whatever the radius is. So here the radius is not a nice number, it's the square root of 6. But we're squaring it. Okay, because this side represents radius to the power of 2. So if the radius is square root of 6, and then we put it to the power of 2, what does the power of 2 do to the square root? Gets rid of it. So the equation would just be x squared plus y squared equals 6, because square undoes square root. Okay? Make sense? All right, and radius has endpoints at 0, 0, and 0, negative 7. Okay, so if you're thinking this one through, we know that the center is 0, 0 here. We know the center is 0, 0 because it says in the question, and the radius has endpoints at 0, 0, and 0, negative 7, which would be down here at 0, negative 7. So that tells you the radius is how long? 7. Is everyone good? The radius would be 7 units. If you count down 7, and that will give you your radius. So then, because the center is 0, 0, we know the left side is x squared plus y squared. And we know the right side is going to be 7. We figured out the radius squared. So the equation is going to be x squared plus y squared equals 49. Okay, is the point negative 5, 4 inside, outside, or on the circle? All right, everybody try this one. I'll give you a chance. You're gonna do. Okay, so move our chart so there's more room on the left side than the right side. Left side is x squared plus y squared. Right side is 40. X is negative 5. So it would be equals bracket negative 5 squared plus y is 4 squared. Remember, when you square a negative number, you get a positive. So you end up getting 41. So the left side doesn't equal the right side. Everybody good? So instead of saying left side equals right side, we're going to say left side is greater than right side. Does that make sense? Left side is greater than the right side, which means negative 5, 4 is outside the circle. So if you got them to be the same, it's on the circle. Left side bigger, it's outside, and left side smaller, it's inside. Okay? You're comparing. And remember, this is greater than. And this is less than. Okay, a circle centered at 0, 0 passes through the point negative 8, 7. Determine the equation of the circle. Check your solution with decimals. Okay. So, because of this, that's centered at 0, 0, we know the left side of the equation is this, correct? But we need to know what r is in order to be able to fill out the right side. We need to know the radius. Agreed? Any ideas of how we could find out the radius? If we know the center's at 0, 0, and it goes through this point. Yeah. Exactly. If I find the distance between those 2 points, that's going to be the radius of the circle. Does that make sense to everybody? So that's the center and a point on the outside. The distance between them is the radius. Okay? So this is going to be my x1, y1 for my distance formula. And this is going to be my x2, y2. So over here, I'm going to put finding radius. And remember, the distance is the radius. So instead of writing d equals if I want to, I could write r equals. Doesn't matter as long as I know that distance I'm finding is the radius. Okay? So then I'm back to using my distance between 2 points formula from this morning. And calculating that out, and that's going to give me my radius. So hopefully everyone got pretty comfortable using this formula this morning. So -8, subtract in the formula 0, which is nice and easy. 7 minus 0. So square root of -8 squared, make sure you have brackets around the -8, plus 7 squared. And we get 64 plus 49. Which is 113 square root of. Does that make sense? Now, this morning I would have changed it to a decimal. But since once I know the radius, I'm going to end up squaring it anyways, I shouldn't bother changing it to a decimal. Okay? So now I'm going to come over here, and I know the left side is x squared plus y squared because the center is 0, 0. And I just figured out the radius was the square root of 113, but that has to be squared. Okay? So squared undoes square root, right? So the equation of the circle just ended up being x squared plus y squared equals 113. And then I'm going to type that into decimals, and you guys are going to check and see if it's centered 0, 0 and it goes through -8, 7. Okay? X squared plus y squared equals 113. Okay, so we want to know if it goes through the point -8. Which is right here, and +7. Yep. Okay. So we got the right equation for the circle. Center 0, 0, and it goes through the point -8, +7. Okay. All right. Let's see what the next question is, but I might not want to start it. Yeah, we're not going to start this one until after lunch. So we can just chill for a couple minutes, and then it'll be lunchtime. So